Okay, it's lesson 2, year 10, the 1.3 booklet, making use of energy. So far we've looked at density and measuring the density of air. We are now going to move on to finding the density of oil. If you read what it says, she's put an empty measuring cylinder on a balance, 112 grams. She's then added some oil, so the mass has gone up to 172 grams. And we've also got a volume of the oil measured from the measuring cylinder. Now it says here, select and use a suitable equation. The equation that we're going to use is, and you could write this down underneath here on the lines here. I shall write it to the side. Density is mass divided by volume. Now to work out the mass, it says show your workings. We take the 172 and we take away the 112. So show your workings. 172 full of oil. Take away 112 no oil. Will give us the mass of the oil, which is 60 grams. The volume of the oil is this value right here, 70, 72, 74, 76. It is 75 centimeters cubed, or 75 milliliters. So you should be explaining each stage in your calculation as well. So you need to give a little bit more information than I've done. So density is mass divided by volume, and that equals 60 grams divided by 75, and that gives us 0.8. That's not quite there yet. We haven't got the units. 0.8 grams per centimeter cubed. State two ways. State two ways in which the density of the oil could be found to a greater accuracy. Well, the measuring cylinders only provide us to 2 centimeters cubed. So if you were to have a measuring cylinder that had a resolution of 1 centimeter cubed or half a centimeter cubed, that would be better, a higher resolution. Similarly, with the mass scales here and here, we are getting values to whole grams. If you had a resolution to 0.1 grams, you get much more accurate data. So it's a higher resolution for both the measuring cylinder and the mass scales. Will get you your 2 marks there. Let us move on. We are now going to watch a video so you can calculate the density of water. Okay, this is video 3 for year 10, the 1.3 booklet. We have looked at the density of air, we've looked at the density of oil, now it's calculating the density of water. So, we can see the mass scales here at 0. I'm going to put on a measuring cylinder. It is empty, and the empty measuring cylinder gives me a reading of 37.24 grams. What I'm going to do now is add in some water. This is a random amount of water, and its volume is, let me just check, it is is 30, 31, 32, 33. It's 34 centimetres cubed. That's the volume, 34 centimetres cubed. Now, the mass has also gone up, and it's gone up to 70.12 grams. That is all the information that we need in order to calculate the density of the water in a measuring cylinder. So here we go. Let's use that information to calculate the density of the water. The mass of the water equals 70.12 take away 37.24, and that gives us a mass of water of, I'm just working it out on my calculator, 32.88 grams. Remember, this value was the measuring cylinder plus the water. This was the empty measuring cylinder. So if you take them away, you work out the mass of the water. Now the volume of the water I read off. That was 34 millilitres or centimetres cubed. So to work out the density equals mass divided by volume. That's worth 1 mark. And then you put in your values, 32.88 divided by 34. That gets you another mark. And finally, you get an answer, and it is to 2 dp, 0.97 grams per centimetre cubed, or 0.97 grams per milliliter. Now that is not a bad figure, because pure water actually has a value of, to 2 decimal places, 1.00 grams per centimetre cubed. That is the end of lesson 2.